Hi, this is Jeff Kish with Network Solutions. Today we're going to be talking about how to build out a DR site. So let's go. All right, so when we're building out a DR site, one of the key things is going to be knowing what exactly we're putting into that disaster recovery location. So first of all, let's define what's at our production side because we need to know what we have there. So at production, we're going to have some servers. However many of those servers that we have. We're going to have some storage, ideally a storage array. Maybe it's all flash or spinning disks, whatever we have there. And more often than not, we're going to have a backup system. So this backup system is usually the starting point for how we're going to keep things safe. So if you've checked out some of the other whiteboard sessions that we've done, we've seen that backup is maybe something that we can use to get back up in the event of a disaster. It won't be as fast, but at least it keeps our data safe. So the question is, what are we doing at the DR site in order to capture that data and make sure that we protect it and be able to get spun back up? So let's do our backup and DR site over here. So some people call it a backup site, some disaster recovery location, whatever you call it. What we're going to do is we need a repository for those backups to start with. So some kind of repository. Now that can be a server, it can be a storage array that's dedicated to just containing the backups. That's an option. So at first glance, what we're going to do, or at a minimum, what we want to do is keep that data safe. So we're going to transfer the data from our production site to the backup site, and that's going to give us some level of DR. Now, the level of DR that gets us, unfortunately, it's not the best, but it can get us back up and running. So let's walk through what that looks like. If all I have at my DR site is a backup repository, I don't have servers, I don't have storage, I have to get those. In the event that the production site is down, I need to spin back up with servers and storage. I have to have those key components. So however long it takes me to get the servers, however long it takes me to get the storage, and on top of that, I have to pull those backups out of the backup system. That's a lengthy process. So unfortunately, what we're really looking at is about probably a 3 to 5 day outage. And now, oftentimes when we talk about outages, we think that we can just go grab some servers from the store or storage, pull it out of the shelf. From a tech perspective, and I've been there, it's just like, wow, 3 to 5 days, that seems like a long time. But it is the reality of it. Nothing goes as planned. We might think that we've got some servers on the shelf and we can pull them off and 2 of them are dead, or maybe we're going to go try to find some servers and storage from maybe our vendor. We're going to call them. Well, they don't have any in stock, or it's in the middle of the night and I can't get a hold of anybody. So it just never quite goes according to plan, unfortunately. And we have to account for that. So what are some ways that we can improve the disaster recovery time? Well, and again, we're looking at our DR site, and we could just get a storage array out there. So what if we got a storage array, and it's sitting out there, and it's a disaster recovery array. If we're all flash over in production, we really probably don't need it to be all flash. It could be a hybrid array. It could be all spinning disks. A lot of organizations, when they refresh the storage array at their production location, they will take the old one and put it at the DR site. I think that's a great way of doing it, especially if it's the same brand. Because, for example, if you have 2 NetApp arrays, you can leverage the native replication features in those arrays and have a replication. So, really, at this point, we have the data replicated and we have our backups. So there's 2 different problems that we're solving there. Yes, the backups are still necessary because in the event that we need to recover files or we need to just go back in time for any reason, that's what the backups are for. Server got corrupted, we got a virus or malware, right? Ransomware hit, we got to go back in time. That's what the backups are for. Replication between the 2 storage arrays is really not about going back in time. It's more about how can I get back online faster? And by replicating between the 2, the data is already live at my DR site. And so I've worked with a lot of organizations that have exactly this configuration. We still don't have servers at the backup site, but we do have a storage array. And we're replicating between the storage arrays. And that's really good. That improves our our time. So the question really is, how long does it take? It depends on how long it takes to get servers, right? My production site is down. I have the ability of spinning up my DR site, but I just need those servers. So how long does that take? I mean, we can throw a number, every organization's different, but I'm going to say somewhere between 24 and 72 hours is about how long that will take. Assuming I can get the server spun up within that first 24 hours, maybe 24 to 36 hours, get those servers spun up and configured, right? We may have to install our hypervisor. And then, of course, we have to attach the storage and pull those volumes out of the storage array from a replicated volume into a live production volume. So that's something to consider as well. So our next step is maybe we can expect would be, what if we could get some servers there as well? And again, just like our storage array, these don't have to be the latest, greatest servers. This could be something that maybe if you've got servers on the shelf, just pull them off and power them on and have them ready, waiting. Maybe it's like we've refreshed our servers and we're going to throw those old servers over there rather than trading them in or something like that. And what that enables us to do is forego the time that we need to find those servers. Really, the process is the same. We're going to, in the event of a disaster, take the replicated volumes on that storage array. We're going to make them live volumes. We're going to spin up our virtual machines. So at that point, really, it's pretty good, especially compared to everything else we've discussed. We're looking at about 4 to 8 hours, hopefully, that we can be back up and running. So that would be number 3. So I want to pause here, though, because we do have one problem that I want to address with all of this, and that is the concept of failback. Because when we get into disaster recovery planning, it's really easy to focus on how do I get back up and running in the event of a disaster. And that's great, other than hopefully that disaster doesn't last forever. Maybe there was an electrical outage in my production site, and it was going to last several days, right? Maybe it's a big snowstorm that hit or some other weather event that took out power, and we don't know how long it's going to be up, or down rather. But it is going to come back up. And so after my organization's been running at the DR site for whether it's 2 hours or 20 hours or multiple days, that is now my live production data. So how do I get that data back over here? And how quickly can I get back over here? That's a difficult question to answer. It depends on which model you're really looking at. Are you relying on your backups? Are we able to swing that replication back over from one array to the other like that? From a server perspective, it doesn't really matter because servers are servers. So we generally just have to reverse the direction, right, and get back up and running. And it takes a while. And so when you talk about how long does it take to fail over, obviously we're not necessarily having to run out and grab servers and storage. We already have that at the production site. But however long it takes to swing that data over, it's going to take that long to swing back. And it's a very painful process. And so ideally, what we can do is deploy some level of DR software. And there are several options out there in the industry. And the DR software is going to take care of a lot of this pain for us. It's going to handle the replication of the data. It's going to handle the failback of the data. In fact, we don't even need to worry anymore about replicating at the storage array level because that disaster recovery software is going to handle that for us. And so the great thing about it is we benefit immensely in every facet. So even from a failover and failback perspective, really we're talking about potentially 15 minutes and under. Most of that DR software is licensed per virtual machine, so we don't necessarily want to target every single virtual machine in the environment. And this is where, if you watch some of the other videos, we discuss how to build out a DR strategy from a tiering perspective. We want to sort our VMs into tiers, and once we've sorted them into tiers, we align them with one of these different levels of failover. So maybe I just rely on my backups. Maybe I rely on my storage array for the critical volumes. But even the storage array replication, having servers available, is still going to take me a significant amount of time to get spun up. Those mission critical workloads that need, I can't lose more than 5 minutes of data, I can't be down for more than 15 minutes, that DR software is going to be a huge hit. So that pretty much explains how to build out a DR site. Again, there's multiple ways of doing it. A lot of it does depend on budget and management buy-in to how long we can afford to be down and how much data we can afford to lose. But we do our best. And the most important thing is we communicate very clearly to management exactly what we have, how long, again, how much data we will lose in an outage, how long we will be down, make sure that they understand that. And if that opens the budget up to be able to do a more sophisticated DR design, then everybody wins in that scenario. So thanks for your time today. Looking forward to the next one.